Hey everyone, in this video I'm going to teach you about chi-squares. So what is the purpose of a chi-square test? A chi-square test is a way for us to check to see if our data is fishy, or in other words, if our data is outside of a reasonable range of tolerance due to randomness. What this means is that if our chi-square test shows us that the data is too fishy or too suspicious, then we can reject our hypothesis on the experiment. So when we evaluate data, not only are we going to look to see if there's any relationships or if there's a difference of the data between a control and experimental group, sometimes we even go in to check, is the experimental group's data acceptable or within an acceptable range of tolerance? Now, to do chi-squares, we use null and alternative hypotheses. Here's what the difference is. Your null hypothesis is a prediction that the experimental data will fall within a reasonable range of tolerance. The alternative hypothesis is the opposite, that the data will not fall within the predicted range of tolerance. Now, once we establish our null and alternative hypotheses, we're going to use a mathematical chart to help us find out if the data does fall within our accepted range of tolerance. Now, to do that, we need to know what the predicted values are and what the actual values in our data set look like. The predicted values are what is known as your expected values. And these values can come from ratios, they can come from percentages, they can be expected probabilities from something, let's say, like a Punnett square or a dihybrid cross or a pedigree. But this is what we predict the values to be. It is worth mentioning that you should always, for expected values, you should always use the numbers themselves, not the percentages. So you'll have to calculate what the expected numbers are. The observed values in our table are going to be the actual values that our experiment comes up with. These can either be given to you in a data table format. Sometimes they will ask you to count the number of the observed values, but this is going to be the experiment itself. So let's practice with this chi-square testing. According to the records, 54% of the students at Round Rock High School are male and 46% are female. In the AP Biology program, there are 284 students in total. So the question is, does the ratio of male to female in the AP Biology program match the ratio of Round Rock High School? So you are given here the percentage of students that was given to you in the background. So 54% are male, 46% are female at Round Rock High School. In the AP Biology program, there's a total of 284 students. And of those 284 students, I counted 79 male and 205 female. So what we want to see is, does the ratio of male to female match the ratio of male to female in all of Round Rock High School? And so we're going to use a chi-square to determine, is this just randomness, or do females prefer AP Biology more than males do? So the first thing we're going to do is establish our null and alternative hypotheses. So remember that your question guides this hypothesis. So your null hypothesis is that the ratio of male to female in AP Biology will match the ratio of male to female at Round Rock High School. And then the alternative hypothesis is going to be the opposite to that. The ratio of male to female in AP Biology will not match the ratio of male to female at Round Rock High School. So this is what a typical chi-square table is going to look like. You have the different categories, your observed values, your expected values, your observed minus your expected minus your expected squared, and please pay attention to where the parentheses are, and then your observed minus the expected square over the expected. So basically what you do is for every for every one of these blocks, you're going to use this information to fill out the next block, and then this fills out the next block, and then this fills out the next block. You have a chart like this underneath question or step number 7. Feel free to fill it out as we go along. So now what we're going to do is we're going to determine the categories for the chi-square table. Think of these as the number of options that are available, and you're going to place those in this far left column over here. So for category 1, we'll put male, and for category 2, we'll put female. Next, you're going to determine your expected values. Remember that these are based on the null hypothesis only, and you're going to calculate the numbers that are expected based on what the null hypothesis states. In this example, we are multiplying the percentages of Round Rock High School students by the total number of students in AP Biology, and we're going to place this in the E column. So for males, I multiplied the percentage of students based on the ratio at Round Rock High School times the number of students in AP Biology, and I get 153.36. For expected values, it's okay to get decimals. Next, I'm going to calculate the expected number of females in AP Biology. And again, I'm going to multiply the total number of students in AP Biology times the percentage of students that should be female. According to our null hypothesis, the ratio of male to female at Round Rock High School should equal the ratio of male to female in AP Biology. That's why I'm multiplying the percentages times the total number of students. Next, we're going to fill in the observed values. These values are given to you. They are the actual numbers that were counted in real life. The number of actual students is given to you in the table. Now we're going to place these in the O column. Now I'm going to fill out the rest of this table by taking this header here and performing the calculation. So I'm going to take the observed minus the expected, and I'm going to place that value here. And notice I'm not rounding any of my decimals. I'm keeping them in place. You don't want to start rounding too early because you will introduce rounding error. Next, I'm going to take the observed minus the expected and I'm going to square it. But pay attention to these parentheses. It's outside of, or the square here is outside of it. So if your value, like this one, is negative, when you take negative 74.36 times negative 74.36, this will come out to a positive value. There should be no negative values in this column here. Next, I'm going to take this value, my observed minus expected squared, and I'm going to divide it by the expected value that was over here. That's going to be filled into this column. To calculate the actual chi-square, what you're going to do is you are going to add up this column right here. So the sum of these two numbers right here are going to equal our chi-square. And for this, you can round to 1 decimal place. This is pretty much our final answer of what our chi-square is going to be. Notice that even though it's got a square here, we don't square root this or we don't square this value. You simply add these two up, and that is what is known as our chi-square. So this is not a mathematical function that you need to complete. It's just there as part of the name. So once you add these two up, that will be our chi-square. Now, this is the value we are going to compare to your chi-square table on your formula sheet. There are lots of numbers on that table, so you need to know specifically which one you're going to compare to. To figure out which number you are going to compare this chi-square to, we're going to need to find the intersection on this table of two specific numbers. The first of which is called your p-value. And in AP Biology, we always use the same p-value of 0.05. You're also going to need to know the degrees of freedom. Now, your degrees of freedom are always going to be the number of categories minus 1. So in this case, we have two categories, male and female. That would mean our degrees of freedom is equal to 2 minus 1, which comes out to be 1. So on your formula sheet, you are given this chi-square table. Once again, in AP Biology, we're going to compare our chi-square. We're going to compare this value here to one of these numbers. We just got to figure out which number we're going to compare it to. So what we do is we use the probability of 0.05. And so your p-value is over here. This is the one we're going to use. And we always use a p-value of 0.05 in AP Biology. Next, we've got to look up our degrees of freedom. And our degrees of freedom are always the number of options, so male and female. We had 2 options, minus 1. And that comes out to 1. Now, you never have to memorize this. This is on your formula sheet. It is given to you. So our degrees of freedom we are going to look at is 1. And that is right here. So this is the column we're going to look at. And where those two intersect is the critical value we are going to use to compare. Now, if your chi-square is less than the critical value, then you fail to reject the null hypothesis. So we're going to compare this value on the table to our actual chi-square, and we're going to make a declaration. If the chi-square is less than the critical value, in other words, if this value is less than this value, then we fail to reject the null hypothesis. If your chi-square is greater than the critical value, then you reject the null hypothesis. So in this case, we are going to reject the null hypothesis. We are going to practice this in class as well as throughout the year. I hope this video was helpful. Thanks for watching.